The ordinary sequential variety of LINQ has plenty of aggregation operators. For example, if you want to calculate the sum of all the elements from 1 to 1000, you just do an enumerable.range from 1 to 1000, and then you say sum. And there are plenty of other aggregation operators which kind of fold the sequence to a single value. For example, there is the average operator. Now, these are all special cases of a more general operator, which is called aggregate. So let's take a look at how this can be used to calculate the sum. By the way, let me output the sum, so I'll write line and we'll say sum equals sum, just so that we can verify we're getting the correct result. So in here, the sum from 1 to, what was it, 1000 is 500,500. Okay, so sum, the operator sum, is actually a special case of the aggregate operator. So we're still doing things sequentially. We're not doing anything multi-threaded, but we can calculate the sum as the following. So we can say that it's actually a enumerable dot range, as always, from 1 to 1000, and then instead of using sum, we'll use a function called aggregate. Now this function, basically at each iteration, it specifies some seed, some starting value. In this case, we'll use 0 as an identity because adding 0 to something doesn't change the result, and then it takes a function of 2 arguments. So the first argument is the element you're iterating, and the second argument is the accumulator. That's what we've started with 0. So we add I to the accumulator on each step, and that's how we get the final value. So here I just say I plus ACC, and if we execute this, well, we're getting exactly the same value. So this has all been sequential, and the question is, how can you do the same thing in a parallel setup? And in fact, you can do it because parallel query also has its own aggregate function. So let's take a look at how this particular method works. So I'll do var sum. Now in this case, I'll do a parallel enumerable just to save us some time. So we'll do parallel enumerable range from 1 to 1000. And then what we're going to do is we're going to call aggregate. So this aggregate, as you can see in the overloads, is a really complicated function. It takes like 4 arguments. So we're going to once again try and take it slow, and I'll actually do separate lines for the different parts. So first of all, just like in the sequential aggregate, you start with a seed, the starting value for each of the calculations. So in this case, since we're doing a sum, we're using a 0. If you were doing, let's say, a multiplication of each element, you'll do a 1 because multiplying by 1 doesn't change the result. So we start with a 0, and then the second function that we provide is the function that happens per task. So remember, we're using lots of different tasks to actually calculate the final value. So we're doing this kind of update accumulator function, what would be executed for each of the elements. So remember that we are working in our case with some sort of partial sum, and we are processing the element I. So for each task, what we're going to do is we're going to take the partial sum and we're going to add the element I, and that's our function. Now the next part is what happens when you combine the results of all the tasks into a single value. So in this case, you want to get a total, and you have a bunch of subtotals. So what you want to do is you want to say total plus equals subtotal, and that way you combine all the partial sums into the final sum. And there is an additional function that you can provide here. You can see that it's kind of taking an int and returning a value. This is a way of post-processing the final result before you return it, kind of like doing a select at the end. But we're not going to do anything here. We're just going to return the final value, and that's our function. So we're now done in doing the sum, but we're doing it in a parallel fashion, and in addition, we're explicitly specifying how the aggregation happens. So if I execute this, well, we're getting the same result. So that's good.